So participants are still joining, but I think we should start the program. So Rohit, yeah.
Oh, okay, sir.
We'll start.
Yes, Vedant, am I audible?
Yeah, Rohit, you're audible.
Okay. A very good afternoon to one and all. I welcome you to the third day with the third session of 2D and 3D modeling in Staad Pro Workshop. It's a privilege to have with us Mr. R. Udayashankar, sir. I welcome you, sir, on behalf of AISSMS College of Engineering. With no more delay, I ask you to take over, sir. Thank you very much.
Thank you, sir. So screen is visible, sir?
Yes, it is loading, sir. It's in the loading screen.
Okay.
Yes, so now it's visible. Okay.
Oh. Yesterday we'll discuss about how to create the 3D frame structure and how to apply the materials and properties, supports. Tomorrow we'll discuss about how self-weight also, our brick load also. Then how to apply the slab loads for our building and how to analyze the earthquake is a large process. We'll discuss about one thing, statical structure. So two methods are and dynamic method. Today we'll discuss about statical method. It's okay, earthquake. It's a large process, but I tell about simply how to analyze in stat pro, how to take the weight of building, how to calculate the base shear value. You take the base shear value, you fix the design and others, etc. Finally, you take the base shear value in pro, but you take the clear value in ETAPS also. It takes the accurate value. Okay. Second procedure is over. The first procedure is self-weight, and the second procedure is brick load is over. Then first of all, I cut this section. I cut this ground floor. How to cut the ground floor? Simply go to tools, go to first of all, go to labels, node numbers, apply. Node numbers. Node numbers. This is my 70th road. I cut this ground floor. How to cut this? Simply go to tools, cut section. This is a XZ plane. Simply click this XZ plane 17. Click OK. So okay. I converted as this is a one-way slab. One-way slab taken into larger beam. This is a square slab. This is a rectangle two-way slab and two-way other slabs. Okay. First of all, how to apply the floor loads? One is the dead load, another one is a live load. The types are that. The dead load is based on your thickness of the slab. It's calculated by manual in this formula. Then live load is taken from IS 875 part 2. Your live taken. So there is a two conditions. One is a dead load, another one is a live load. So okay. I simply go to I apply the two methods are there applying the load. One is the grouping method, another one is a direction method. The two methods are there. I tell about also. First of all, I apply this load on this slab. First of all, I create the load. Go to, first of all, I this slab. This is also two-way slab. How to create the groups means Ctrl plus G is a grouping. Grouping for beams and columns, others, etc. I create the floor. This is called square slab. Then this select type. The select type is a floor. Then click OK. Go to assign this. This is our square slab. Select this all the square slabs. Two-way slab, this slab. Right. Simply select the square slab. Then go to associated to selected geometry. Simply associate. Automatically the square slab will be added in our group. Simply go to Ctrl Z. Go to, first of all, select this one, this, and this. This is a one-way slab. Simply go to create. This is a one-way slab. Then go to flow, like that, click OK. Then associated selected geometry, associate. Automatically the one-way slab will be created. Next one is a square slab. Two-way. This all parts are two-way slab. I select this all the parts. I select this all the parts. Then go to, I select this also. Then go to create. This is a two-way. Then go to floor. Okay. Then associated to selected geometry, associate. Automatically create a square slab, one-way slab, and a two-way slab. This is the first power grouping of your slab. Then how to apply the loads? This is a dead load. Simply go to load cast detail, add, dead, add. You change the name also. Click this load case 3. Go to edit. Automatically edit the slab dead load. Change that. Simply slab dead load. Simply go to add. Go to floor loads. This is our floor load. How to apply the floor load? How to apply the floor loads? Wait, your thickness of the concrete is 130 mm. Okay, 130 into 25 unit weight of concrete. Simple. Yeah, how to calculate the dead weight? The thickness of the my slab is 130 mm. Into unit weight of the concrete is 3.25. My weight. Our floor finish is 1. The minimum floor finish is 0.75 to 1.5. I added my total dead load is 4.25. This is a gravity. Simply go to minus 4.25. Then go to group. Click this group. I already created the square slab for this load. Go to included floor, add, close. Says automatically our square slab will be added. Next one, the square slab floor thickness, slab thickness is 130. Is another one-way slab is a different. It's a 150 mm thickness. So you created another one floor load, slab dead load, add, go to floor load is a 150. The 150 means 0.15 into 0.15 into 25 equal to 3.75 plus 1, our floor finish 4.75 minus 4.75. Click this group. This is a one-way slab. Included floor. Your one-way slab means click this one-way distribution. This is a main important one. It's your one-way slab means click this one-way distribution. Two-way slab, unclick this. One-way slab, you click this one-way slab. Simply add, close. This is a square slab distribution. One-way distribution, load acting on only. Yesterday we will discuss about the one-way slab is distributed this two longer span sides. This the two longer sides. This automatically it will be distributed. The next one, square slab. The square slab 160 mm thickness. Go to add, floor. I take my dead weight is 4. The included my floor finish is 1, totally 5. Go to group, two-way, included floor. Do not click this one-way distribution. This is a two-way slab. Simply add, close. Click this. Automatically, the two-way distribution will be taken. It will be automatically when it is square slab. It will be take automatically distribution as a square slab. This automatically it's created. These are all two-way slab and one-way slab. This is square slab is this is creating of the slabs and others. Then how to see the values of load distribution? Then right click on the mouse, go to labels, then go to labels, then go to load values, apply OK. See this automatically your load distribution values. Load distribution values. This is a one-way load distribution. This one-way load distribution per meter is a 7.2. This are the two and the other distribution. This is a one slab. Simply go to tools, cut section, show all. You created the one by one all the slabs. Understand? One by one all the slab. There is another one method. Another one method. This is simply go to cut section. This is 33. Simply go to tools, cut section, XZ plan 33. Okay. Then click this. Then go to click this dimension. Click this dimension. Go to dimension. This is a 3 meter by 3 meter. This is a 4 meter. All the meters. Then another method is the same procedure. Go to slab dead load. Then go to add slab dead load. Then go to add as the same procedure. You will create all the procedure for load creation. Something is different. Other method, the grouping method. Another method is go to floor slab, go to floor slab, then go to our dead weight for second floor is minus 4.5 added as a included to our dead load and floor weight. Then how to create all the floors? This is the range method. To create a group method is one method. The another method is a range method. Our height is a totally floors, right? Height is a 0, not a 0. Already created. Our floor height is a starting height is a 3 meter. This floor is a 3 meter. Ending with 3, 6, 9, 12. Okay. Simply click 12. Starting x direction is a 0. Ending is a 3. And z also 0. Ending with 3. Simply click add. Close. See this. Simply go to tools, set cut section. So what? See this automatically it's taken into all the floors. So I have 2 floors are there. Go to click this add. Go to height is a 15, 18. I change the height is a 18. Automatically it's created all the floors. This is method. Simply go to 33 tools, cut section is a 33. Then I created the one-way slab for all the. Simply go to load, add, floor load. Then our pressure is a dead load plus 4.5 is a 5. Then this is the minimum is a 3. The maximum height is a 18. Our X range is a 0. Starting range is a our Z starting is a 3. Then Z ending is a overall distance. 4 plus 4 8, 8 plus 3 11. Simply click this 11. This is a one-way distribution. Simply click this one-way distribution and close this. Then go to tools, cut section, show all. See this. All the floors will be created the one-way load distribution. This is another method. Simply go to 33. Go to tools, cut section. X is a 33. Okay. Then I created all the two-way slabs. Same procedure. Simply go to dead load, add. Simply go to dead load, add floor load. Then our total load is 4.5. The two-way slab height is the same. Minimum is a 3, the maximum is a 18. Our x distance is starting from this point. X is 3, ending with the total distance. 3 plus 4 is a 7. 7 plus 5 is a 12. The x distance ending with a 12. Then is a distance. Isn't it starting from 0, ending with the 4 plus 4, 8. 8 plus 3, 11. Simply click this 11. Then add, close. This, then go, sorry, put the minus. Okay. Simply go to the gravity. Simply go to minus, change it. Then go to select, go to tools, set cut section, show all. Says all the floor loads will be created. One-way distribution, two-way distribution, and other square line. This is another method. I will create the dead load, the same procedure as a live load also. Cut this portion, 17 node. Simply go to tools, cut section, XZ 17. 17, okay. Then go to, I created the live load. Go to load cache details, add. Then go to this is the live load. Then change the name, live load. Live load, add. Then go to live load, add this. Same, go to floor load as per IS 875. You give the different live loads for your floors. As per IS 875 part 2, one of your you take the education building or residential building, 114 different from the loads. This is the hall means is a 2 kN per meter square. This is the shop store room. This is the toilet is a 1 kN different from as per IS 875 part 2. Okay, I put the same load for the all the section. Simply go to -2. So okay, I simply go to -2. Same procedure is starting from bottom. This is 0.02 total 18 meter. Okay, X is a square slab. X is a 3. Sorry, X is a 0. This point, this is a 3 meter. Simply click this 3. Then go to result also 3. Then add, close. This the live load will be taken to all the floors. Next live load, one-way slab. Go to add. Go to floor load. So -3 for one-way slab. 0 to total height 18. X range is a 0. This range is a 3. Simply click this 3. Z is starting from 3. Ending is a total distance. 4 plus 4, 8. 8 plus 3, 11. Then click this one-way distribution. Add, close. This automatically it will be created. Another two-way slab. Go to live load. Then go to floor load. Then click this minus 3.5. Then go to our total height is 18. Our X starting point is this point. Starting point is 3. Ending point is this point. Total distance 4 plus 5, 9. 9 plus 3, 11. Total distance is 11. Same. Minimum is it is a 0. The maximum is 4 plus 4, 8. 8 plus 3, 11. It's okay. Sorry, this is a 12. X is a 12, right? X is a 12. This is 11. Simply add, close. This automatically it will be created. Go to tools, cut section, show all. This it will be created the live load also. This is our dead load also. This is our load case. This big load also different types of load cases. Simply give the same load for all portion. You will be designed give the 5 or 8 loads. This is a concept to given the loads for your building. I put the self-weight, brick loads, and a dead load for your building and live loads. Then simply go to combination, load case details, define combination, all the loads, factor of safety 1.5, like this 1.5, 1.5, all the loads are 1.5. Simply click this, add, close. This is automatically all the loads are converted into 1.5. There is a 14 kN for my brick load. This is self load, floor dead, and floor live load. This is a 1.5 for self-fired. Then go to analyze, add, close, analyze, run, analyze, save. That is the procedure. This is the different from yesterday and today. Yesterday is a 2D structure. It's a no floor. Today will be 3D structure. So floor is there. We will be create the floor. We will be apply the floor loads for this different one-way and two-way square slabs. Then I created the model and analyze my structure. Then how to see the values? Post processing. I take combination load only. Click this combination. I take the combination. Okay. This combination. I disable to my dimensions. Tools, dimension beams. Remove the dimensions. This is our deflection. L by D ratio. Check it. Main one is a bending moment. This is our bending moment for this whole structure. Yesterday we'll discuss about briefly how to take the reinforcement for our bending moment. This is the main thing to design the bending moments for your whole building. Simply go to result, view value, beam result, bending moments. Annotate. This is the overall bending moment. I will see the one bending, one beam means simply click this beam, shear bending. This is click this automatically combination. Our bending is a direction. This is a bending. This is a bending moment. This is a bending moment. See this distance. This is a moment. Automatically it will be given for your structure distance and the moment. The maximum moment will be given. And click this point. Click this point. Bending moment. Automatically it's give the bending for your structure. This is a dead load. I need a combination load. See this is the bottom bending moment is a 19.5. This end is a 39.5. You take the cross section 3 cross section also. You take this is a 19 only, provide the minimum reinforcement. This is a 13 only, you take the higher reinforcement. Now understand how to take the reinforcement detailing in your buildings. Okay. This is a you take a single beam, use this value. Otherwise, you go for tables also. You go to this tables. You see the tables, bending moment tables, and other tables also in post processing. See this. This is our bending moment tables. Horizontal force and bending moment combination, bending moment for us. You see this single beam. Like this, automatically any beam automatically show the values for your bending moment, shear force, and deflection values. Local deflection, global deflection. Go to click this combination load, see this deflection for your values. This is the main concept for seeing the bending moment. One is shear force. Shear force is the FY direction. Unclick this bending moment and deflection also. Then see this shear force value. Then how to see this single beam shear force? Click this. Then go to shear bending, click this Y. This automatically go to combination load. Combination, the force is high in two corners. This is the 67 and this is the 73. But the mid portion is shear is 0. You provided the stirrups is less spacing, for this center will be high spacing. This is the concept. And bending also same concept. The bottom portion tension zone is 0 and 44. You provide the additional reinforcement. Center portion, the tension portion is a needed reinforcement. The compression zone is no reinforcement needed. Then go to this bottom. Same procedure is needed for no tension reinforcement. It's needed for compression reinforcement. That is the condition for this area. Now understand. This is the reinforcement. You click this automatically. It will be changed for this values. This is 56. I need the center value. Automatically click this center value. This is a dimension. I need the center value. Click this automatically. It's the center value. Or otherwise, this might be 1.5. Click this is 1.5. I need this 3-meter beam or 2 meters. 2 meter. This is center. Click this automatically. The shear value is 2 meters and base 1. This is the method to seeing the single beam in Staad Pro. See the values for your values for your bending moment, shears and others, etc. You see, simply click this. I need this beam. Simply click this. Then go to shear. Then go to click this combination load. Then go to bending. I need a mid of the portion 2 meter. Simply click this automatically. What bending will be occurred and shear force will be given. This portion end is high. This end is high. Our mid portion is 2.5. Is this you provided 2 cross. This is a minimum to group this one cross section, but this is a 67. Is a smaller. You provided the 2 cross sections and shear also. The shear will be high in these 2 corners. 121.21, 161. The rate steps will be less in this portion. The mid will be increase the height, increase the length in stirrups, but 2 corners you reduce the stirrups length. Okay, this is the showing. This is see the single beams in Staad Pro. Okay, this post processing you will be see the all the values. You otherwise you see the single values. Will be simply click this single beam. You see the single value for this section. Next one, how much load acting on your footing? Go to reactions. This is automatically. It will be some difficult to see this. This one, our first column. This is a column 1. Our load is on column 559 for this bottom floor. This is our second column. This is the third column is 1241. This is a 25. This column is a 2328 load. It's a high load. Then these are the loads transferred to a footing, column to footing. Now understand. This is the main one. This loading is calculated from the footing side. Okay. This is the second step is over. This is the processing step. The next step is the design step. How to design the model? Yesterday pressure also. Simply go to design, go to concrete design, then go to IS456, then go to select parameters, then go to pressure strength, yield strength, main, and this click OK, then go to tools, set current input units, meter and Newton. Click OK. Define parameters. I take M25, add. Then this is the FE415. Click this FE415 and secondary also FE415. Add. Then go to assign the material for your floor. FE415 assign to assign yes. Then FE415 assign yes. FE415 assign yes. I assign the material. Then design. Click this command. Design column. Add. Then go to click this design beam. Then to select beam parallel to X and select parallel to dash. Selected beams. Yes. Next, beam parallel to Y direction. Assign yes. Analyze, run, analyze, save. You take the reinforcement detailing for our column and beams. Click this slab. You will be take the automatically design this and take the values only. Click this column. This column. See this percentage of steel percentage. And this column says automatically this column. I click the center column. This column is not designed. Why? the load will be not taken this column. So you redesign this column. See this, simply go to section. Okay. This is the fifth section. Simply go to tools, cut section, go to this is the XY plane, fifth one, okay. Click this column, this no design. This is also there are no designs. Why? It will be high. The column size will be smaller. So increase the column size. This is also high. How to increase the column size? Go to general properties. Go to define rectangular. I increase my column size is a 230 by I increase 550. Add close. I select this column only. Then assign yes. Then go to analyze run. Done. Then go to click this. These are no values will be taken, not design. So increase the sizes also. Simply go to edit, go to 600. The load will be high. I change 600. Go to analyze, run analyze, save. Done. Click this. Now it's not taken. I simply is my width of the column width is a it is there. I increase the 250. So okay, change yes. Then go to analyze, run analyze, yes. Done. No. So increase the sizes also. This simply delete. Go to this is a 250. I change the 2 width by through 300 by 600. Yes. The load will be that is the problem. Simply click this. Since automatically it will be designed. Why there is a problem? The load will be and the moment will be high. The load is 2000 kilonewton, but the column size will be smaller. That is a problem. This is a method to redesign this all the structures. That is the conditions. Okay. You go for 300, but sometimes you will be provided 300 by 450. It will be designed. You go for 230. Increase this beam width. Sorry, column depth. That is a condition. But you not architecture purpose. You will be increase the width also. So okay. Now it's clear how to redesign structure. Simply change the sizes automatically. It will be create the redesign the structure. All the things same thing. Click this. This one I click this. Then go to assign yes. See, simply go to click this. Sorry, change it and analyze this one. Once you change properties in your steps, done. Then go to click this. Automatically see this. Your concrete will be positive. Your column will be. That is a condition. This is a redesign method. Trial and error method. Once you fail your column or beam, change your design. Then select your all the columns. Then you change the column sizes and get the results also. Beam will be maximum will be passed. Sometimes the column will be failed. That is a condition. We will be check it all. This is our concrete column. This is AISSMS 2.42 20 mm bars will be 8 numbers of bars will be provided. The load and moment will be acting. Our grade of column and the grade of steels will be provided. This is the condition to design the beam and the column. How to redesign it? Simply click this all the column numbers. It's a fail means it's not redesigned. then go to properties and resize the columns will design will be processed. This is a method to redesign your columns and beams also. Okay, understand how to design your columns and beams, etc. There is a method to design your 3D structure. Yesterday we'll how to create the 3D model. Today we'll give the acting and the flow load and other etc. In movement and same procedure as a design and movement and sorry design and beam design value. Is another one that is a concrete design. So, okay, take a maps. Take a detailing diagram for your column and beam also. Okay, this is a column and beam. How to see the column and beam design? This design it will be detailing diagram for your column and beams. This is the RC designer, concrete RC designer. You simply go to first 5 steps are there. One is the envelope, the another one is a member, another one is a groups and briefs, another one is a design. These are the 5 numbers to design in your numbers. Okay. So the 5 numbers. One is a envelope. Simply click name. Anyone name. I will be H. Click O. The combination load. I take the combination load. I click this side into this side. I click this combination load. Okay. Then I design the column number. I design the column number. Simply go to member. I click this column member. Then go to members. Go to auto form member. This is the second step. Go to member. Click this auto form member. Then third step is a groups and briefs. Okay. The groups and briefs is nothing but you give the concrete grades and steel grades also in this position also. RC designer also you will give the concrete grades and others etc. First one will be create the new brief. This name anyone name. This is a column. I create the column. This is a column code. IS456. This is my RC code. Then this is a column. Click OK. This automatically this dialog box will be open. Whatever you need automatically will be changed. I grade of concrete M20. I click this M20. This is a cover. This is a rebar. I need a 500. This is a links 250 or anyone. I put this 250. This is a bar size and others etc. This is a column factor, the basing others, the load case. This I take the combination load on click this side to this side. Then click OK. Then go to new group. Go to new design group. This is the same one. This is a column. Select this name column. Then OK. Automatically the name will be appeared. First step is the envelope. Second groups and member. Third step is the groups and briefs. The next step is the design. This is one, right? Select this. Right click on your mouse. Add members to design group. Click this. Add members to design group. Add. Then OK. Automatically as a number. Then go to more member design. Automatically this is a column, major axis, minor axis. Then go to design. Automatically first I will create the member. I select this member design. This is automatically my major and minor axis bars will be passed and shear also might be okay. Then how to see the other values? Go to main layout. This is a main layout for my column diagram. Then go to shear layout. Then go to results. This is our column. This is the load of this my column, and this is my C5 is my location line. The column line is a C5 is my location line. Then this is my axial load. This is my moment, minor moment. The biaxial area required and provide automatically. It will be take the your number of area of your and my moment by your the next one. This is the same like a shear force. This is our shear value, the position, and this value is the direction, then area required and spacing will be provided the required and other spacing. So, okay, will be take the your load and which rods and others etc. and shear values and others etc. Then the detailed drawing, simply go to shape this internal section. How to change the sizes? Simply go to this A. So I change 1:10. It's longer. I simply go to 1:50. Then smaller, I change 1:33.5. You change the sizes also. I change this 1:33.5. I change this drawing sheet, say A4, you took the landscape or portrait, then go to this AutoCAD format, DFX format, then click OK. Automatically this drawing will be exported in AutoCAD. Automatically open the AutoCAD, edited the column detailing drawing also. You go to schedule, you take the drawing also. This is my type of bars or 8 mm dia, 12 mm dia, number of bars. 12 mm dia, 8 bars will be provided. This is the links will be provided. The bar length also provided. The link length, the bar name shapes and sections will be provided. A, B, B. This is the full details taken in RC Designer. Same as the beam also. Okay. Same as simply go to design layer, envelope. I create the beam. The second one is the beam. Okay. Click this. The load taken to combination load. Okay. Then go to I select this beam. Anyone select this beam number. Automatically its member will be created in this. Then to groups and briefs. Then go to new brief beam. This is a beam IS4 phases. You change into beam. Okay. These are the beam values. Our top cover, bottom cover, and side cover. You need it. We will be changed. Then our grade of concrete M25. We will be assigned the value also. I give the M25. Then how many segments you do? Segment. I need the 12 segments or 50 segments. You will be segmented into the beam, divided into the beam. 1 meter is the 1 meter of the beam divided into 12 segments. That is a 12 segments. This is a designing for torsion. I click this designing for torsions. I change the main reinforcement. And the main reinforcement is a maximum. I put this minimum bar is 16 mm. The maximum bar is 25. The links are 10 mm dia. I change the 10 mm by same bottom bar criteria also 16 is a 25. This is also links also 10 mm. This is a grade is a 500 main bar. This is side bar criteria. More than 750 mm, you will be provide the side bar criteria. Okay. Then shear reinforcement. This is 3 conditions: incline load effect, column face, etc. I simply click this column faces. I provide the 10. This is a shear. I need 2-legged or 3-legged or 4-legged. I provide the 2-legged. Then grade of bar 4 and 5. I click this shear bars for links only. I simply in this value, simply click OK. Go to new design group. It's a beam. Select this beam. OK. Then go to select the beam. Same procedure. Right click. Add to design group. Add. OK. Then go to mode. Member design. Says automatically your design span and others, etc. Then go to design. Select this. Then go to design. Go to add member. Add. Sorry, this is group. Sorry, this is a beam. Add. This is once you created, automatically save. Then go to design. Click this. Design is the M2 or beam. Select auto beam type. Hacking and sagging is okay. Shear bars are okay. Span by depth ratios are okay. So all are will check in RC designer is okay. Then go to how to check the main reinforcement. Simply click this main reinforcement. Our bars are there. This is our moment area. This AST required. The AST provided for top bars and bottom bar. It should be gives in clear. This is a hacking and sagging. It should be given the sagging, how many bars will be provided, and the sagging also provided. Simply click this and we will be taken the value. Shear arrangement. See this, the shear will be divided into 12 parts. This is started from 0 from 4. The 12, see the shear is higher in 2 corners. So the shear stress is higher. Then the area required for shear stirrups. This will be shear value. Then how to take the drawing for beam? Simply go to schedule, go to same like that. You will be change the size 1:10. This is too longer 1:20. You will be change that. Okay, sizes and others, etc. There is a DFX file. You will be simply click OK. Automatically exported into AutoCAD. Okay, simply open in your AutoCAD for column detailing diagram, the beam detailing diagram also. This is the detail for the type of bars. T16 will be used, 10 will be used. Number of bars, 4 bars will be used for this reinforcement. So 31 is the length of bars and others. This is the shape code. This is the another length. This is the total bar length, etc. Now understand how to design in RC designer. The RC designer will take the diagram also. And the shear values, all the values, take clear values. You'll be share the drawings and export and others. You will be understand this how to analyze in RC designer. This is a normal designer. The RC design like accordance and the detailing works and others, etc. How to create the 3D structure, then how to analyze structure, then how to take the shows bending, reinforcement, detailings, and other values. Okay, then go for earthquake analysis. Okay, then I go for earthquake analysis. Earthquake is a large part. I will be take a small part for this earthquake. Okay, this is a large spot, like so many conditions in our earthquake. I'll be take the small part for this earthquakes. I go in this earthquake code book. So now is updated for IS 1983-2016, but it's an older one. Staad is an older one, so I just take this IS 83-2002. There's a two methods are there: static and dynamic methods. Already studied in your PG and UG also. Earthquake resistance spectrum analysis, response spectrum analysis, time analysis. The static method is a normal method to calculate your shape, bearing, etc. The dynamic method is a analyze the response spectrum and time analysis, etc. So today we'll discuss about how to create the values for static method, how to take in the weights and others, etc., and how to calculate the base values and others. So, okay. The first of all, I simply create the one model. So, okay. Simply go to new, space this next, yes, finish. Simply created this 0. Next is only one way. I created this 4. I go for translation repeat, or otherwise 0. 4 is a width, and another 4 is a 4. I created only one way. It's a easy understand. Then go to node, then click this node, then go to y direction 3 meter, one step translation repeat. Okay. Then go to geometry, add beam from point to point. Click this. Then go to select command, select this same dimension. Simply go to translation, y direction 3 meter, only one. Okay. This automatically created the G+1 building as same as a G+1 building unless the earthwork structure. It's going for G+5 or 6, so many floors, it will be confusion. We will be analyze the simple flow. It will be easily. How to calculate the building weights and others, etc. Okay. First of all, already known about the earthquake. Earthquake is a magnitude will be affected the building in the bottom in mainly. So many things are there to resist the earthquake structure. One is the base isolation techniques are there, roller techniques. So many techniques are there. Otherwise, you will be considered the reinforcement also. Ductility detailing code book is there. You provide the additional reinforcement for earthquake. That is a method to design the additional reinforcement provided for detailing method. Okay. So many dampers are there, viscous dampers. This type of dampers and others are there to resist. First of all, the basic is the static method. The simple way. Anyone, how to analyze the earthquake building? How to analyze the earthquake structure? You take a load or weight, mass. Anyone? You simply analyze your earthquake structure in your building. You convert as a load or mass. You convert as a load or mass. You convert it as a load or mass. Anyone? Okay. Any earthquake structure will be designed means the load will be converted as a mass. Okay. You take the weight only. You analyze the earthquake structure. Now understand. Earthquake structure, you will be analyze the buildings. Okay. What are the procedures are there? What are the procedures? The first one, what are the procedures to analyze in your building? This all the photos are taken from this code book 1983 2002. Okay, all the pictures I insert the one Excel sheet. So, okay. First condition is a zone factor. The what is meant by zone factor? Which zone your building will be adopted? That is the main one, zone factor. Which zone? There are 4 zones are there. 4 zones. One is a zone 1. Zone 1 is no. It will be taken out. Zone 1. Otherwise, zone 2, zone 4, and zone. These are the first factor for zone. Which zone your building will be adopted. That is the first condition. Our zone 2 means it's a low seismic intensity. Zone 3 is a moderate. Zone 4 is a severe. And zone 5 is a very severe. This is enough a zone. You find also your places also that maps will be given. See this. This is our maps for this area. Intensity of sun. See this. This is zone factor for. This is zones, zone 2, zone 3. The area also given. Your area Chennai or Delhi or Mumbai, any other, or Bangalore. The Bangalore is comes under zone 2. Our value is totally 4 zones are there. Zone 2, zone 3. Sorry, zone 2, zone 3, zone 4, zone 5. Only 4 zones are there. But the 4 zones are all the states will be sorry. It's okay. These are all taken into is a zone 3. It's 3. And Kolkata is a zone 3. You states and places are other. This is the first step. Assumption my building is adopted in zone 3. Okay. For example, my building is adopted in zone 3. Assumption. I take the assumption in zone 3. Okay. This is a zone factor. I click this zone factor. My building in this zone 3. This is a zone 3. Moderate our zone value is 0.16. Okay, 0.16 our zone value. Next one, importance factor. You take the importance factor earthquake analysis. What is meant by important factor? Nothing but building type. What type of your building? Important factor. See this is our important factor I. The second one is the important factor. Your building is a hospital, schools, and emergency building, telephone. One. Your residential buildings and other buildings are give the response. Importance factor is a 1. That is a condition. Depend on your building. Your important building is you give the important factor, you give 1.5. The normal your residential building and other buildings, you give the 1 also. So okay, I will change the 1. The important factor is 1 for my building. This is the second step for the earthquake. First one is which zone will be adopted for your building. That zone wise you will be provided. Next one, what type of your building? Important building or unimportant building? 2 types. Important building means community calls, hospitals, etc. Unimportant building means you go to residential buildings sometimes, etc. My building is a residential building. So my important factor is a 1. That's the method based on your conditions. Okay. The third one is a response reduction factor. The third one, I'm taking the earthquake analysis. The third one is a response reduction factor for your building, R value. The R value is taken also IS 8. All the values are IS 87 as 1. How to take the response reduction value? This is the building. What type of building? This is also same. What type of this is the type of building important factor. This is the response reduction factors of what type of structure you are building. Okay. These are different types of structures. One is an ordinary RC moment resisting frame. One is a special moment resisting frame. Another steel frames and steel moment resisting. So many of that. My building is a special RC moment resisting frame only. Okay. Special moment resisting frame. I take this response reduction factor. If you take this other building, you will be steel, you will be take the 4 or 8 wall structure. You will be steel or concrete, vessel moment resistance, RC moment resistance. My building is a RC moment resistance. So take the 5. Next one is the soil type. This is the soil type. What type of soil in your building? G value. What type of soil in your building? The 3 types of soils are classified. One is the rocky or hard soil, and medium soil, soft clay soils. Depend upon the values. The SG values, S by G values, 2.5, 2.5. How to take this 2.5 values? My soil condition is a hard rock. Okay, for example, my soil condition is a hard rock. Then my SHG value is a 2.5. How to take the 2.5? This is the seconds. Okay. the time seconds. How to take this time, calculate the time seconds? Simply go to this formula. This is the approximate fundamental natural period. Okay, this fundamental natural period based will you take the SAG value. This fundamental natural period take the SAG value. Our formula is 0.09 into H root of D. Okay, simply you calculated this formula. Simply you calculated our building 0.09 into H. Okay, H of the building. Our height of the building is 336 meters. Okay, our height of building is 6 meter. Simply click the 6. Our width and length of the building. Width the length also 4 and our width also 4. So automatically it will change the value is 0.27 seconds. 0.2 seconds. This is the dimension. Simply go to tools, go to dimension beams, display. This is the x direction is a 4 meter, z direction of 4 meter. So I simply length of the building is a 4, width of the building is a 4 meter. Just this is the Excel sheet. You also prepare. It's a simple formula. I will prepare this Excel sheet, not a big formulas. This is a 6 meter of the building. Okay. Then click this automatically. This is a formula. This formula is 0.09 into H into root of D. H is height, total 6. D is a distance, 4 meter, X distance. You take the two directions. The two direction is 4 meters, so it will be same. The X direction will be 6 meter, Y Z direction will be 4 meter. The automatically the time period will be changed. Okay, the time, for example, for this is a width. Changes with the portion is a 6 meter. See this automatically our time period is a 0.22. The based on your width and the length. It is a width, length is a X direction, width is a Z directions. Okay, length is the X direction, Z is a Z direction. So automatically I calculated my time period for X direction is a 0.27 seconds and Z direction is a 0.27 seconds. Then go to my soil condition. This is a fundamental frequency time here. Then go to for my rocky soil. This is my rocky soil. Then go to the time period 0.10 to 0.4 seconds. My soil comes under seconds 0.27. I go this is a 0.002 0.10 is not this condition. The second condition is 0.10 to 0.04. The third is 0.4. My condition adopted in second one. Okay, my condition adoption 0.4. So I take the 2.5. You will be lesser than 0.1 sec, 2 sec, 0.6. You will be take this 1 plus 15 t. So okay, time seconds into time seconds divided by time seconds. Okay, take this. Next one is a medium soil. You will be take this 2.5 and hard soil different will be taken. Now understand how to take the SAG value. Rock or soil and then calculate the fundamental time period. The fundamental time period formula is this is the height of your building, base dimension in X direction of your building. Simply calculated the fundamental natural period. Then go to class this table IS 1983. Then see the second condition is adopted 0.1 to 0.4. So I take the for SAG value. Okay, SAG value. Next, I got same the time fundamental time period will be calculated. So I simply calculated the first one zone factor. I will be take the I adopted the zone 3 in my building, and one is a non all building general building. This is my moment resisting frame. My building. I calculated the fundamental time period for my building. 20 is 0.20 seconds. Based on my take the soil conditions to the table one is a AH value. What is meant by AH means designing spectrum, the seismic force. Designing spectrum for the designing horizontal seismic coefficient is a AH. Okay, horizontal seismic coefficient. What purpose we will be calculate the horizontal seismic coefficient? The finally go for base seismic base shear calculation. The formula is the AH into weight. So AH is a designing coefficient into weight of your building. You calculated the base shear. So you calculated the horizontal seismic coefficient. The next step is a horizontal AH is a horizontal seismic coefficient. The horizontal seismic coefficient is the formula is ZISAG by 2 into 2GR. Okay, this is also automatically it will be calculated. This also its formula will be based. So okay, simply go to Z is there. Z is our important zone factor. I also there. Important factor 1 SAG by value is calculated hard rock or rock 2.5, and then 2 is formula response factor is 5. Will be easily calculated your horizontal seismic coefficient. Now understand how to calculate the horizontal seismic coefficient. This is our formula AH into ZI by SAG 2R. Already I calculated the zone factor, important factor, SE rock value, then response reduction factor. Simply calculated automatically the response reduction value, AH seismic horizontal coefficient values will be calculated. There is a basic formula only, but then this will be changed automatically. This value only change, but this is two value are same, so it's the value, all the values are same. Now understand, the finally you calculated the base shear. The base shear formula is AH into W, horizontal coefficient. Your formula is horizontal. How to calculate the horizontal coefficient? You need the zone factor, important factor, reduction factor. That purpose only you calculated the zone factor, important factor, reduction factors, etc. Now understand how to take the values. Then this is not a final value. Then this is the final value. The finally you go for small. The finally the seismic base shear. That is a formula is a AH into W. Okay. Our calculation is a AH is a 0.04, but our weight is not calculated. Okay. Our weight is the weight calculation. So many procedures there. I will manual that. I simply analyze some stat and take the weight of your buildings. Okay. Simply go to final step is step. You will be calculated this one. This formula is you calculated the different flow for seismic base shears. This formula is you already studied in PG and UG also, and this formula is total base shear, but this formula is calculated by different floor levels. The base shear occurs in this formula is using for calculated the different floors for base shear. This is calculated base shear. Okay. Now understand the zone factor. What purpose you calculated the zone factors, important factors, rock value, the fundamental time frequency, and then the horizontal coefficient value. The finally you calculate the coefficient needed for your zone factor. So that purpose it will be calculated all the things. Okay, you will be called the base shear. We will be provide the additional reinforcement for our buildings. Okay, now understand how to take the values. This all the pictures are in our code books. So all the pictures, this formula, all the formulas are using into the earthquake structures. Okay, will be simply calculated. This is one formula that I tell about later. Okay. Okay. Now understand what are the using in seismic static analysis. Then go for Staad, directly analyze this building. Okay. Then go to this building, same project, go to general, material, concrete, assign to view, then go for property. I take this whole property. All properties are 0.3 by 300 meter, 0.2 by 300. Assign to assign. Then go to support, fixed support. Then go to create, fixed, add, select, control, select this. Select, yes. I simply select this, all the supports. The next one is the load. That is a different. You calculated the earthquake forces for your buildings. Okay. Then go to load and definition. This is the main procedure to apply your extraction. First of all, you simply apply the loads for your same procedure. Go to load case details, add first procedure. First of all, you create the any load. You will be create the earthquake load is the first, then create dead load and live load, etc. Okay, understand. First of all, normal building, you create any load in first is no problem. You create the earthquake building. The first is you create the earthquake load, then create the another loads. Okay, create the another loads. Simply go to load case details, add okay, this is seismic. I change what is the direction will be calculated. That is some different 2016 will be updated. That y direction will be what type of structures we will be calculated the y direction also. Ex direction is okay. Add. I created the two boxes. Then go to add. Go to dead load. Okay, this is my building dead load. And next one is the live load. The UBC is nothing but Universal Building Code. It's not our code. It's the IS 456 our code. This is the live load. First of all, I create direction is our live load. This is our dead load. Okay. Then you created the first of all you apply the dead loads and live loads. Then go for earthquake definitions. Okay. Simply go to dead load, add, go to self-weight, add, close, self-weight, assign to view, assign, yes. Self-weight, assign, next to dead load, member load is a brick load. Simply go to member load, then go to uniform IS 875 minus 15, add, close, then select the select beam parallel to X direction, select beam parallel to Z direction, assign to selected beams, yes. I will assign this loads. Okay. Then next one, slab dead loads. Simply go to add. Okay. Go to floor load is a minus included my floor minus 3. Then same procedure. I will follow this 0 to 6 meter. Then X is 0 to 4. Is that also 0 to 4? Then go to add. Close. This automatically the load will be, dead load will be acted. Then live load, go to live load, add member load, sorry, live load, floor load -2, -2 approximately 0 to 6 meter. Then this is a 4 meter and this is also 4 meter. Add. The live load will be acted and dead load will be acted. Then go to, you will be created this all the loads. One is the earthwork X direction, Y direction. Then self-weight, brick load is a dead and live load. Then you will be created the earthquakes. How to create the same procedure? You will be created this. You created this table. Zone factor same as you will be same values apply in Staad Pro also same value apply in. So okay, simply go to Staad, go to definitions, seismic definition, add. So, okay, definition. Then go to our IS code is IS 1893. 1893 to okay. Simply go to generate. So some problem to generate. I will apply this value for this condition. Your software you will be generate. You will be apply this value. My software some problem. I apply on this value. First zone factor. What is the zone factor? Our zone factor is it? I taken this table. Zone factor is a 0.16. Okay, our zone is 0.16. I taken the IS 1893. Go to Staad. Is it 0.16? Next one, response reduction factor. Our response reduction factor R value is 5. I have taken this. My structure is vessel moment resisting structure. I will take the 5. Simply go to apply this 5. Next, important factor. Important factor also normal building only. My building. So important factor also 1. Based on this important factor, I value is all other buildings. So I apply the other buildings. The type of structure. You will be type of structure is the same structure. I will give you 1. You will be go to generate. Is the type of structure will be given. I will give the type of structure is a 1. The damping ratio is the 5.5%. So I provided the 0.05%. Okay, 0.05% is the damping ratio is for all the building. In earthquake is a 0.0%. Next, period in X direction. Period in Z direction seconds. Already it will be calculated. Already it's calculated, right? Fundamental frequency. 0.27 seconds, 0.27 seconds based on in this table. This is based on this formula. It's calculated the fundamental frequency 0.27, 0.27. Simply go to enter it 0.27. This is also 0.27. So you will need to find this value. Otherwise, this is a response oscillation. Other values are as dynamic method. Static means you apply the zone factor, response important factor, the rock and soil condition. First soil is hard soil, so 1. Type of structure also 1. Damping ratio is 0.05. We already calculated in this natural frequency 0.27 seconds. This is also 0.2 seconds. Okay. Then you need the accidental load. Click this. Otherwise, additional loads will be calculated. The part 4. I do not need this. Simply go to add. It's okay. Simply I click this there. This area will be converted into weight. You apply the weight for your structure. The two methods are there. One is you created the self weight. You click this one. You load means you get the minus. The weight is only give the values, not a minus. Okay. One method is the self weight. I need a 1. Click add the member load for the structure. Select the member and add this and the floor loads. My floor load for live and dead, click add this, automatically apply for the weight. Another method is directly copy this loads and paste this seismic values. Okay, copy these loads and seismic. The two methods are there. One is the added in this value. Cell 1, the member load already given 15 kilonewton for the weight, and then element weight is not given. The floor weight dead load is 3, and the live load also 2. This will be given. Then go to, this is the one method. Another method is that go to Staad editor, copy and paste this load onto seismic definition. So okay, simply copy and paste onto seismic definition. Simply go to Staad editor. Okay, simply click this Staad editor. This is Staad editor. You will be create all the things. It will be entered in this command. The first of all, the creation of the stats is the coordination method, and developed it will be commands. First of all, you create the coordinate methods only. This is easy only. First of all, I separate these portions. This is our concrete grade. This is our member property. This is our fixed end. I simply enter this. I differentiate into star. See, this is the one. The another one is this is seismic weight and others. I simply click enter. Simply click this. This automatically it will be given. These are the values and these are the values. Then I simply go to this live load, other dead load and load type. Simply copy this, copy, then go to this one, enter, simply paste this. Paste this, automatically it will be paste this. Then go to, you delete the load 3, load type, delete this. Then go to take a minus, is a weight, simply plus. You click this, take a y direction also. Then go to, this is a member load. You change the value for member weight. Okay, this is not a load, this is a weight. You take the also minus value and zy value also. Then next one is a floor load. You convert it into floor weight. You change the floor weight, then you take the minus 3. Okay, just take the zy direction. Then next is a live load. You simply delete this live load. Simply click this differentiate. Click this values. Then go to floor weight. Okay. You will be simply and copies this is the self weight. You take the minus value and y direction value. Then member load is changed into member weight. Then you check the y direction and the minus value. Same the floor weight. You will be take the y direction and gy direction minus value. Then you go for floor weight in live load. This is a -2. It's taken to 0.75. Okay. What purpose you will be the 0.75? This is a one condition is there. Once again, I tell about that condition. Okay. First of all, I simply save this, close this. Yeah, close this. Then go to this Excel sheet. This is the condition. This is the one condition is there. The weight will be applied, but the live load is a table. Our live load, this is a live load. The up to included 3 kilonewton, you take the 25% of the live total weight to your load. The more than 3 kilonewton, you take the 50% of the weight. Okay, live load. Our live load is a 2%. I take 25% of the live load. Okay, that is a condition. There are two conditions there. Your live load will be less than 3, you take the 25%. Our live load will be more than 3, you take the 50% of the live load. I simply go to Staad editor, then go to our live load. I taken into 0.75. 1 minus 2.5 is a 0.75. I take the GY direction, then go to save. Put the save and close this. Solve this. Okay. Then go to see this automatically. Our seismic definition. Click this, automatically added our self weight, our member load. Then go to member load, automatically will be added. Our floor weight will be added. Another one, live load. It's a live load will be added. It's converted as a all of its weight. This is an easy method. Otherwise, you will be called. You will be in this method, two methods. Otherwise, you apply the load on this, or otherwise copy and paste for this method. Okay. First of all, I go to load case. I will be create the load X. Load is it live load and dead load. Then go for seismic definition. Already it will be created. Then I created the seismic definition and weight, member, unit weight, and floor weight, live load, etc. Then I added the X direction, Y direction. Simply click this earthquake X direction, add. Click this add. Then go to seismic loads in X direction, add. Then go to Z direction, add. Simply go to Z direction, seismic loads, Z direction, two direction, add. Automatically, all the values will be X direction and Z direction. Our floor weights also, it will be calculated. The next step is the analyze step. Simply go to analyze, add, close, analyze, run analyze, save. So okay, 0 warning, 0 1 error. That's a UBC condition. There's no problem. That is a UBC condition will be is given. So there is no problem. UBC analysis on tension and compression. This is our period of already taken. This is our result. This is a frequency period is a 0.27. It's automatically it's calculated our period of 7.27. This is our soil condition is a 2.5. This is our load factor is a 1. This is a how to calculate the base shear value. AH horizontal coefficient series automatically Staad will be calculated. The horizontal coefficient is a 0.04. Check your manual calculation. Your horizontal coefficient. Check your horizontal coefficient series automatically. Our manual also 0.04 our horizontal coefficient. Our Staad coefficient also 0.04. It's correct. This is a weight 691.04 our weight. Simply go to our sheet. This is a weight 691. 691. I will click this. Then see this automatically. This is our base shear. The base shear, the formula is AH horizontal coefficient to weight. Already calculated manually the horizontal coefficient Staad are equal. I taken the weight in Staad 691. Is this into formula? This into this automatically it will be calculated the base shear value for 27.64. Okay, it will be calculated. Then other methods also there. This is the next one is to be completed. I check this base shear and others etc. Then go to post processing. I take the dead load and live load. So, okay, I take this dead load and live. I take this dead load and live load. Okay. For this condition, go to post processing. Click this deflection, control and scroll this. Sorry, it's take a dead load. You take a earthquake. Will be automatically. It will be given. Simply click this. Right click, then go to support reaction tables. Okay, simply go to support reaction table. This is our support reaction table. You will be calculated this load and this load are same. Okay, this load and this load are same. How to calculate the support reaction table? Simply click this Simply click this copy, go to paste it. Automatically simply click this paste options. Okay, simply click this, then drag this automatically. This is a 731. I need a dead load and a live load for this my base shear. How to change this dead load? Simply go to filter. I take this filter, then go to I need this live load, dead load only, live load or dead load. I simply take this dead load. See this, automatically our dead load are 666 dead load. Then our live load are simply go to our live load. It is totally 65. Our dead load and live load are 65. Then go to calculate. Automatically wait. So 65 into 0.25. Our weight is a 0.25 equal to 65 into 0.25 in live load, totally 16, equal to this one plus this one. Click this side. Plus this one. This load plus this load. Click this. Our load is 682.2. Okay. As simply it will be calculated. This load is total 682. Then check this earthquake frequency. You check this earthquake frequency also. Simply go to right click, go to result setup. I take this earthquake forces. Click this. Okay. Then support reactions tables is a x direction and z direction. You check this same, it will be calculated on this base shear and others also in this value. Simply click this, copy and paste, it will be created. So this is 691. Our values also same like a 691. The Staad will be higher. This is 692. This live load and dead load will be, it will be same. You calculated the same values also. You put this value, automatically calculated the same base shear also. This is 27. You will be check the base shear means simply go to support reaction table. Yeah. Click this, copy, then go to click this, paste, right? Then go to click this, set or filter. Okay. Then you change the x direction. Simply click this x direction and this add this value. See this automatically 28 values will be given. Staad value automatically fx direction is a 28. Our value is a base shear value is our base shear value is a 27.64. Automatically it will be correct, right? 28 our x value same as a 28. It will be correct. It will be automatically it will be check this values. You take the live load and dead load values. It will be calculated into value. Then directly go to you take the earthquake x direction to y direction. You take the x direction only, add this earthquake forces. You will be calculated the base shear also. Now understand how to take the base shear and check this other method. You will be see this is a manual calculation. It's a weight as a Staad. You will be calculated as a dead load and live load. Then you go for manual. Then you directly calculated the Staad value also. The Staad value is totally calculated direction. Fx is a 28 base. This is the load taken from 691. You simply go to 691. It's automatically into AH. Automatically it's calculated the base shear. This base shear and this base shear are same. Okay. Now understand how to calculate the base shear values. The method to check the base shear and other properties. Okay. You calculate the manual also. You will the parameters dead load, weight, and live load. You will be take the weights and others. Okay. So okay. I will complete this section now itself. Tomorrow we will discuss on wind load and trusses, etc. So okay. Thank you. Any doubt will ask me.
Thank you so much, sir. A request to all the participants, if anyone has any questions or doubts regarding the Staad Pro software and concepts that has been covered till now, please raise your hands and we shall unmute you to ask the questions, or you can simply put your questions in the chat box. Please raise your hands if you have any questions. Vedant, do we see anybody raising the hand?
No, Rohit, I guess no. Okay, so participants, if you have any questions from today's session, you can also ask sir in tomorrow's session. Okay. So Rohit, I think we should move forward. Yeah.
Okay. Once again, thank you so much, sir. This was indeed a very informative session. We look forward towards your next session that will be held tomorrow. The feedback and the attendance link for today's session is shared in the chat box. I request all the participants to give the feedback and attendance. Also, tomorrow's session is on the topic analysis and design of roof trusses. All the participants are requested to join through the same Zoom meeting link tomorrow at 2:30 p.m. sharp. Thank you everyone for joining in and see you all tomorrow.
Thank you, sir.
Thank you so much, sir. Yeah. Thank you.
Thank you, sir.
Everyone just with the feedback and give your attendance, and then I'll wait for 5 minutes.